In this video, I'm going to talk about determining whether a polynomial is even or odd in terms of its function symmetry. And I use the word polynomial intentionally. This is only going to apply to polynomial functions. We're not going to talk about square root functions or absolute value functions or any of that other stuff in this particular video. That'll be another topic. So what I want you to look at on the left is all these polynomials. And for each one, we can apply the test that I've written on the right. We plug in a value and determine what the result is of plugging in that value. Now, if the value is negative x that you plug in, and the result you get is exactly the same as what you started with, it's an even function. Okay, I just described this. Whereas if you plug in negative x and you get exactly the opposite of the original function, then it's odd. Now, if it's neither even nor odd, then we call it neither. But I'll go through some examples here. Let's pick, let's pick this one right here. This looks like a fun one to start with. I'm going to plug in negative x. So watch what happens. F of negative x is going to be equal to 5 times negative x cubed plus 4 times negative x. Okay, now as we cube the negative x, watch what happens. That turns into, think negative x times negative x times negative x. There's 3 negatives, so that becomes a negative x cubed. Plus, we still have this 4 times negative x. And now let's bring what's inside the parentheses outside. We'll distribute the 5 multiplier. This becomes negative 5x cubed minus 4x. And if I want, for argument's sake, I can factor out a negative, right? A factor of negative 1. So this becomes negative times 5x cubed plus 4x. I'm not trying to hoodwink anyone. You hopefully see how that progression goes. Now take a look back at the original function. Do you see how the only difference between what I got in the end and the original is a negative sign times the entire thing? That means this is odd. Okay, that's an odd function. Now I'm going to erase this, and I'm going to show you an even function and how that plays out to be exactly the same. It may seem weird that you can plug in a negative and nothing changes, but let's try this guy right here. Okay. F of negative x equals 4 times negative x squared minus 6. So what happens when you square a negative? Well, it becomes a positive, right? So now we have 4 times x squared minus 6, which if you distribute the 4, just becomes 4x squared minus 6. And if you compare that to the original, it is exactly the same. So this one we call even. Now, a neither function would be something that simply doesn't give you the same as what you started with. And I'll give you an example of one of those. So if you take a look at this top one, okay, I'm going to do this one right here. I don't want to spend a whole lot of time on this. F of negative x equals, if you cube negative x inside here, you're going to get x cubed. But if you square negative x, it's going to make the negative disappear, and you'll just end up with negative 8x squared. Now go ahead and work through that in a little more detail like I did earlier if you would like, just to prove it to yourself. But this is what you would get in the end. And if you take a look, you notice that's the same, but that one's different. So this function is not entirely the same as what we started with, and it's not entirely opposite. So this would be an example of neither. Now, this is a great exercise, and if you enjoy evaluating polynomials, then you can have a lot of fun with it, but I want to give you a shortcut. The way to tell real quick if a polynomial is even, all exponents are even. That's it. If all the exponents are even, then it's an even function. And if you look at this one that I did earlier, that has an exponent of 2, that's even. This one is x to the 0 power. That's another even number also. So the trick worked out there just great. Now for odd functions, you might guess, all exponents are odd. If you take a look at the version we did earlier, 3 was an odd number, and this 1 exponent right there, that's also an odd number. So I eventually get to the point where I just check the exponents, and that determines the symmetry of the polynomial for me.